Hello, I'm going to give a quick walk through my signature project. The data set that I chose was a data set about animal shelter intakes and outcomes from an Austin, Texas animal shelter. It had about 77,000 rows, 38 columns. All the data was categorical. The data set was obtained from Kaggle. So I downloaded it as a CSV and read it into R. So my problem statement and what I was trying to predict was shelter outcomes for cats. So were they adopted? Were they returned to their original owner? Were they transferred? I was also trying to predict the amount of time spent in the shelter for cats. And I also did a clustering analysis for dogs, taking into account age and breed. And then the rest of the other types of animals, I did an exploration of outcomes for them just by graphing, so no predictive modeling. So for the data exploration, I created bar charts of most of the data and the subsetted data. So I subsetted by animal type, and then I did some exploratory graphing for each of the animal types. And I ran the summary and glimpse functions to see the overview of each variable. So I have some bar charts for breeds, intake types, outcome types, length of time spent in shelter for dogs and cats. And then I also made the same types of bar charts for birds, livestock, and bats. So this is just a little example of what those look like. I did some data transformations. So first I created a quote unquote key column to be a unique identifier by combining each animal ID and their intake date and time. And then I used that to deduplicate the data because there were quite a few duplicate rows. So that unique identifier helped with that. And there were quite a few instances where I had to reorder factor levels for animals' ages and shelter stay times to go in chronological order rather than alphabetical order, because all of the ages and shelter stay times were essentially binned categories. You know, it was like 7 to 12 weeks, 12 weeks to 6 months. So like those were the binned categories. And then in many cases, I converted the strings to factors. So for example, one of those types of transformations can be seen here. Here's a bar chart for the number of cats by age when they were intaken into the shelter. I then reordered the levels because initially they were in alphabetical order, and so they were not in chronological order. So I did reorder them and then replot them to see the distribution a little bit more clearly. So that was pretty helpful for the visual interpretation of those levels, and also for the encoding later on. There was also a bit of imputation of NA values. So that was something that I had to do in the transformation stage. So now we're going to go through the creation of the models. So for cats, I did modeling of outcomes and shelter stay times with neural networks and SVMs. I also did an analysis of those two variables with naive Bayes. I ran a k-fold cross-validation, and I performed the ensemble model on the cats data. And then for dogs, I did some k-means clustering because much of the data was in the data set already one-hot encoded, which made it easy to do the clustering. And for other animals, I just did some graphing with no actual modeling involved. So model performance. So let's look at the cats data set first. So for the ANN and SVM models, quite a bit of encoding had to be done. So this is where I did all of that. And that was actually quite a few lines of code in order to do that. As you can see here, all of this is encoding the variables. And then I did some scaling, and then we have the models here. So for the neural network, I built one with one hidden node, and then I built one with two sets of two hidden nodes using this this resource here, for the multi-class neural network model. And then I ran this SVM. And so I had split the data into a training set and a validation set. And so I used the validation data to figure out the accuracy of the model on this data. And then I built a naive Bayes model as well. So that didn't require quite as much data prep because there was no encoding. Just had to make sure all of the columns were converted to factors. And then, creating the model and running it on the validation data, and then using the cross table to calculate the accuracy. And then for the dogs data subset, I did a one-hot encoding for only the necessary variables. So I kept breed and age. And then, so that was the data prep. And then I encoded the outcomes, created the dummy variables for those, and then built a k-means clustering model. And so I used 9 clusters because there were 9 levels of in the outcomes variable. So I figure one cluster for each level that we're looking at. Let's just run that and see what that looks like. And so I did some graphing of this the overall picture of the k-means clustering. And so the bar chart here shows each individual cluster and its makeup per outcome. And then we have, the key to match up the graph with the human readable outcomes. So that is what I did for the dogs data. So for the cats data set, the outcomes were quite accurate for, or the predictions were quite accurate for outcomes. So the 2 ANN models gave us around 91.4% accuracy. The SVM gave us 94.02. And then the naive Bayes across all categories was about 93% accurate on the validation data. For amount of time spent in shelter, the prediction accuracy on the validation data was quite a bit lower. And I think I have a hypothesis as to why that is. Some of the bins had an overlap. So for example, one of the bins was 0 to 7 days, and then the next bin was 1 week. And so I think that kind of has some data entry integrity consistency issues baked into it, because one person could say it was 7 days, one person could say it was 1 week. And so the data entry possibly being inconsistent across those bins in a place where the bins the boundaries of the bins overlapped, that might possibly be a reason why we were seeing that. And so here's that graph I showed earlier for the dogs data. And so here's my favorite part of this project, was taking the predictions and bringing them into real life. So I have a cat. This is my cat in this picture. And I made a data frame of his profile from when he was adopted. So he was adopted at 1 year old. He's a brown and white tabby, domestic short hair, came into the shelter in normal conditions. So knowing all of those things, I created a data frame and then ran it through the naive Bayes model for both outcomes and time spent in the shelter. And both of those predictions that the model made for my cat were correct. They matched up with what actually happened in real life. So it was really cool to see the models working on, some real life data, and to kind of make the analysis a little more personal in that way. So for validating models, I used the validation data set to calculate accuracy for ANN, SVM, and naive Bayes. So that was a pretty standard practice. Random sampling, splitting the data set, and then using the validation data to calculate accuracy. Then I did a k-fold cross validation on the cat's data with 10 folds to calculate precision for outcome type and time spent in shelter. And it appears that these models are very precise. All of the 10 folds had the same values for both. So that was pretty cool to see the precision coming out high. So as far as the ensemble model, because there was a data mismatch between the naive Bayes and the normalized data, I would say that the ensemble model was probably the weak point of this project for me. I did manage to create the ensemble model to compare just the ANN and SVM predictions, because the naive Bayes model was text, and the ANN and SVM were like normalized, encoded numerical data. And so it was a little difficult to evaluate the result as well, because the predicted result came out with many more levels than the validation data set with the normalization. So the comparisons weren't one-to-one. So it came out a little odd, but the function did work. It was just like the output was a little difficult to sort out. And so in conclusion, working solely categorical data presents some unique challenges. You are going to have to do a lot of encoding, a lot of data prep for things like ANN and SVM models. There's no, you can't do regression on categorical data, so you have to stick to classification modeling, and the issues with the binning that came to light as I was analyzing it. I think that could be a reason why the time and shelter models were a little bit less accurate. So I think, despite those challenges, I was able to build a number of models that performed quite well against the validation data. And as far as lessons learned, if I were to do this analysis over again, I may do some more feature engineering of the binned time-based variables. So that might take away some of that perceived overlap of the upper and lower bounds of each binned time period. And then that might allow us to train more accurate models. And how can this kind of data analysis be beneficial in the outside world? This type of analysis might allow animal shelters to understand their animals better and to provide better care for their animals, and increase, improve the outcomes of the animals and increase the number of pets who find their forever homes, or, you know, are returned to their owner, or, you know, any number of other positive outcomes for pets. So, you know, we like to see data analysis doing some good in the world. And I think that, you know, looking at these kinds of things could really improve the lives of animals. So yeah, thank you for listening to my video demo. And yeah,